In this video, I will demonstrate how to create an application file from the tree of PCT that can be used to replace a VMA 1400 controller. Now here's the HVAC profile that was uploaded from a VMA 1400, and again, this was used in video 1. It's pressure independent, it's got an integrated actuator, a series fan, it's cooling only, uses warmer cooler adjust, there's no occupancy button, no occupancy sensor, and it does use warm up via a shared supply air temperature over the network. Again, we also have some of the different flow points. So here's the area, which is 0.196, the pickup gain 0.744, and we also have the minimum and maximum flow set points of 250 CFM max and 100 CFM min. Our first step is to go to PCT and create a new application. We can give it a name of N2 PCV tree, and let's just call it address. Since it's address 5, we'll put a 5 there. And the system type is a VAV controller, and it is single duct. Click OK to bring up the tree. Now we'll just go ahead and fill out the tree just like we would with a backnet PCV controller. It's got an integrated actuator. It's got a box fan, and it is series fan, single speed. No heating, so we'll deselect that. We don't want to add the supply air temperature or the morning warm up because we want to use a network variable for that. We have a set point adjust for our temperature with a warmer cooler adjust. And now you can see here we have the network warm up cool down support selected. Click finished. And once our code comes up, we can start modifying it. Now the first modification we'll need is to pull this down and change the zone temperature from a network sensor to a nickel sensor. Since this was a metastat. Then we'll need to change the warmer cooler to resistive. And again, it already defaults to plus or minus 5, which is what the setting that was inside of our VMA controller. Then we have an occupied mode that we can just go ahead and delete since we're not going to use an NS sensor. Now we can go to the balancer override and view the details and modify that. Our max flow was 250 CFM. Our min flow was 100 CFM. Heating flow in warm up at least was 100. Our area was 0.196. And our K factor was 0.744. Now apply that, and that sets up our flow. Next, we can go to the details of the zone set point determination. And right now, the occupied cooling set point is 74. The occupied heating set point is 70. So we'll have a 4-degree offset from between the effective cooling set point and the effective heating set point. So if you want that tighter, all we need to do is go ahead and adjust that. So instead of 74, let's set it as 72, which will be 2 degrees between the two. So if we have a 71-degree common set point, the cooling would be set at 72 and the heating set point would be 70. We can apply that and close that. Now we need to go to the define hardware. And this is where we go ahead and change the N2 PCV from a PCV 1630 to the PCV 1832, which is our N2 product. We go through next again, look at our terminations. Next again, we'll change the address to 5. Now that we've sourced this application file to our N2 PCV, the PCV 1832, we can go and open the Advanced tab. And the Advanced tab will have the N2 mappings. Now in the pre-builts, our engineers have defined these points and mapped the N2 protocol to match the N2 points in the VMA 1420. We could do the same here. So if we want to go ahead and address these, we could make sure that these points, this N2 protocol exactly matched that of our VMA 1400. Or we could go ahead and just click generate mapping and it will map everything sequentially. Now if these points are internal points, and we don't have to worry about the aux schedule because that's a network input, and you can write to the present value of aux schedule, which happens to be a network variable. However, if we have internal points that aren't network variables and we want to write to them, we cannot write to the present value. And let's look at the parameters for the analog data flow. And let's just take a look at what points we may want to write to. And so this cooling unoccupied min flow, if we want to write to it, we need to change it from the present value to the default value, the cooling standby set point. So we'll need to just go ahead and change these points that need to be written to from present value to default value. And then we can go ahead and write through those from our network. All right, so I'll go ahead and apply all those. Again, you need to change anything that you need to write to for the network. And now I can take this application file and save it. And we have a finished application file that can go ahead and be downloaded into the N2 PCV controller. And this is a application file that was created from the tree.